My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 620. In this lecture, we will try to understand ResNet. ResNet is a short form for residual networks. So, there is a short form for residual networks. This is a very interesting research work from Microsoft Research. Just observe this one, this URL, what it says. Here you have 1512 means research paper published in the year 2015 in what is that? This number 12 indicates, 15 indicates year 2015. This number 12 indicates in the month of December. So ResNets were published in late 2015. Very interesting idea from Microsoft Research. Idea has this motivation. We will go through some of the concepts in this paper, and I will also show you some of the diagrams to understand it in better manner. If you observe this research paper is called Deep Residual Learning for Image Recognition. In ResNet, the res comes from residual and the network. The core problem that the researchers in Microsoft was noticed this. If you take simple network like your VGG16, the regular networks are called plain networks. So in this paper, the regular networks are called plain networks without this residual concept. Isn't it? What is a plain network? Or regular networks are called plain networks. These are the networks without residual concept. So what they realized was, so in a plain network, so if you had 20 layers network versus 56 layers network, this is the training error. Just see on y-axis you have training error. This is iterations. On x-axis I have iterations. This is training error. On y-axis I have training error. On x-axis I have iterations. And if you observe second diagram, on y-axis I have test error. On x-axis I have iteration numbers. One thing that we noticed is as the number of layers increase from 20 to 56, both the training error and test error of a 56 layers neural network, convolutional neural networks, of course, was worse than 20 layers. Even after we use dropouts, ReLU, remember we are using dropout, ReLU, all these interesting ideas. Even after all of these, our very deep neural networks like 56 layer neural networks was performing worse than 20 layers neural network. Why is this happening? How could we fix it? If you are using a plain network like VGG16, modified version of VGG16, remember VGG16 has 16 layers. So instead of 16 layers, if you increase to 56 layers, you can always increase to 56 layers. What they noticed was both the training error and the test error, isn't it? Both the training error and the test error of a very deep neural networks like 56 layer, 100 layer neural network was worse than 20 layers. They did lot of research and came up with very interesting idea called residual unit or identity unit. Their idea is as follows. Their idea is this is called residual block or identity block. I will explain you why it is. This is new piece of building. This is a new piece of building block. This new piece of building block they have created. Building block works like this. Imagine I may have neural network. Just let me say I may have neural network here, some big neural network, many layers. this is our basic building, this is our building block. This above this one, I have big neural network. I can say big in the sense neural networks with many layers, isn't it? I may have neural network here also after this block also. Yes, I may have neural network here also. Here we are assuming before this block we have neural network. Even after this block, let's assume I have a neural network. I may have neural network after this block, after after this. What is this? This is this particular residual block. This is somewhere in between. Amongst all your layers, let's assume your input is here. Let me say my input. This is my input. Just let me assume like this. This is my input. This is my output. In between these, suppose there are two layers here. Both are convolutional layers, of course. Suppose the output of these are two layers. Just observe this one. This is one layer, weighted layer. This is another weighted layer. There, suppose the output of the previous layer, let's assume, is x. Let me say the output of the previous layer is x. What is x? This is my x. This is output of my previous layer. That's important. So there is something here in between. Above this there is some more layer, isn't it? This above this there are some more layers. Even after this also there are some more layers. Before this before this residual block there are some layers. Even after this residual block residual building block, there are some more layers after this particular block, even before this particular block. This is this particular block is somewhere in between. Suppose the output from the previous layer output comes after ReLU. Yes, after ReLU. Just observe output from previous layer. The output comes after ReLU. Remember, you have ReLU here, isn't it? Which generates this x. This x is generated by ReLU. This x is generated by ReLU, isn't it? That's important. That's why I'm writing. From where I am getting this x which is generated, ReLU is generating this, because look at it. What do we do? Convolution plus ReLU. That's the operation, isn't it? Convolution plus ReLU. In the above part, what we used to do here neural network, here you have, here what you used to do? Convolution plus ReLU, isn't it? What this x is coming from ReLU. It is an output from this x is an output from ReLU. I can say wait, this x is, I can say this x is output from ReLU, which is x here. Now this x now goes into bunch of weights. Weight layers could be, what is this? This weight layers could be bunch of kernels or fully connected weight layers. This could be a bunch of kernels, isn't it? Also you perform convolution operator and then ReLU activation, and then you have bunch of weight layers, and then you perform ReLU operation. Just ignore this line for a second. So what do we have? We have x here. Just see, we have x here. We have a bunch of weights. Let me assume we have a bunch of weights. We are performing convolution like operations, and then we use ReLU. You perform convolution or dot product. Convolution if it is an image, convolution if it is an image, dot product if it is a vector, isn't it? This x is coming, this particular x, just observe, this x is coming out of a ReLU. That's important. This ReLU now goes into one more layer. Just assume this ReLU will goes to one more layer, if you observe this ReLU is going to here this ReLU is going to one more layer. That's, I can say, convolution layer, and then this convolution is going to ReLU. Isn't that? That's what the structure says. There are more layers after this. Just observe. If you observe, there are more layers after this. Here you have more layers. Where here you have more layers. Here also you have more layers, isn't it? There are more layers after this. After this, in the sense, after this one, you have more layers after this. Isn't it? There are more layers before this. Before also you have more layers. After also you have more layers. What residual learning introduces? The new concept called residual block or identity block, isn't it? The concept is very, very interesting. I request all of you to go through these concepts so that I will continue my discussion in my next lecture, that is in lecture number 621. Thank you very much.